Next is covalent bond. The chemical bond formed between two combining atoms by mutual sharing of one or more electron pairs is called a covalent bond. And the compound which is formed is called covalent compound. Now, suppose both the atoms, if it is a bond between a metal and a non-metal, then the metal loses or metal donates electron and the non-metal accepts electron. But suppose both the atoms are of non-metal, then none of the atoms are ready to part with their electrons. So in that case, what they do, they share electrons. The pair of electrons are shared by both of the atoms. So mutual sharing of one or more electron pairs. Now in this bond, each atom contributes an equal number. In this mutual sharing, each atom contributes equal number of electrons. Suppose one pair of electron is shared, then both the atoms give one electron and form an electron pair. If two pairs are shared, then the 4 electrons are involved in it, 2 from each of the atoms. Let us see some examples. Hydrogen, chlorine molecule, oxygen, nitrogen, these molecules. Let us see the formation of these molecules. The number of electron pairs shared is called the covalency. Hydrogen. Before combination, hydrogen, the dot structure, we are drawing the dot structure. The other hydrogen atom also has 1 electron. Let's draw this with a yellow electron. Now, when combination takes place, both of them share this pair of electron. That is, they come together and both the hydrogen atoms make use of this shared pair. In this way, this also reaches the noble gas configuration, helium, and this also reaches the noble gas configuration. So if you have to draw the dot diagram, you draw it just like that. If you have to draw for class 9, orbit diagram is also there. So in that case, we write it this way. We show the sharing. Next is chlorine. Chlorine has 1, 2, 3, 4, 5, 6, 7 electrons. The other chlorine also has 1, 2, 3, 4, 5, 6, 7 electrons. When they share, suppose this is with yellow. Now electrons don't look like dots, it's just a way, or neither it is yellow or white in color. It's just a way of representing. So when they come together, they share a pair of electrons in which both are equal. Mutual sharing of electron takes place and the pair of electron is from both the chlorine atoms. So this pair of electron is shared, and ultimately here also we write hydrogen, covalent bond, hydrogen. These are not electrostatic forces because there's no question of any ion formation over here. So these are weak molecular forces only, Van der Waals forces they are called. Now here it is chlorine, in between, Van der Waals forces exist in between the molecules. So chlorine, bond, chlorine. These are all single bonded. Now let's see one double bond, double covalent bond, oxygen. 2, 6. So if we write the dot diagram of oxygen, then we are not writing the orbital diagram is only for class, orbit diagram is only for class 9, and dot diagram is for class 10. Oxygen, dot diagram of oxygen. 2, 6. So 1, 2, 3, 4, 5, 6. In Levy's dot diagram, only the outermost shell configuration is written. That means the electrons present in the outermost shell only is written around the atom. Next, oxygen atom. 1, 2, 3, 4, 5, 5, 6. This is also 2,6 structure. Now, when the sharing takes place, this also needs 2 electrons because it has only 6. This also needs 2 electrons. Both the atoms need 2 electrons to complete their octet. So, they will be sharing 2 pairs of electron. 1, 2, 3, 4, 5, 6. This way. So, if 2 pairs of electrons are shared, then a double covalent bond is formed. Now, nitrogen molecule. Nitrogen 2, 5 is the electronic configuration. So, we will draw 5 electrons here, and the next nitrogen atom with 1, 2, 3, 4, 5. These are the 2 the combining atoms. This requires, there are only 5, so it requires how many more? 3 more electrons to complete its octet. So, they will share, both of them require 3 more electrons, so they will share these 3 pairs of electrons, and a triple covalent bond will be formed. A triple covalent bond will be formed. These 2 will be remaining as it is. Now, let's see some molecules where 2 different atoms means atoms, 1 of nitrogen and 3 of hydrogen have combined. These are the molecules of compound. What we were doing till now were the molecules of the elements. Same type of atoms were combining. Now, let's see the NH3. Nitrogen has 5 electrons, 5 valence electrons, and hydrogen has 1 valence electron. So, when they combine, they'll come close and they will form a shared pair. I'm drawing it here only. So, they will form these are nitrogen's own and 1 of hydrogen. Hydrogen I am representing with yellow. And this will not take part in bonding. So, 3 covalent bonds will be formed. 1 covalent bond by sharing 1 of nitrogen, 1 of hydrogen, the same here and over here. So, nitrogen, single covalent bond, hydrogen, nitrogen is bonded to the 3 hydrogen, and these 2 electrons which did not participate in bonding, this is called the lone pair of electron. Lone pair of electron. So, 3 covalent bonds, and these are shared pair of electron where bond is forming. It is called shared pair of electron, and this is called the lone pair of electron. So, the lone pair, nitrogen has a lone pair of electron. Let's see water. Dot structure of water. Oxygen has 1, 2, 3, 6 electrons in its outermost shell. So, it needs 2 more. It will share with hydrogen. I am writing the combined structure. So, 2 of hydrogen's electron oxygen will be sharing. This actually belongs to the hydrogen. Now, hydrogen is also making use of, because hydrogen is reaching helium structure in this way. This hydrogen has this atom, but it will be sharing with oxygen, and oxygen also reaches 8. 1, 2, 3, 4, 5, 6, 7, 8. This and this is shared pair, and these two are the lone pairs. So oxygen has 2 lone pairs left and 2 covalent bonds with hydrogen. CH4. Let's take this methane. Carbon. How many electrons did carbon have? Valence electron. Atomic number is 6, so valence electrons are only 4. 2, 4. That is the configuration. So it needs 4 more electrons. So it will share hydrogen's electron, and in this way it will form 4 single covalent bonds with hydrogen. You may write before combination and after combination, but I have written it all together. So how many covalent bonds are formed now? Hydrogen. This is methane. Let's see what happens in ethene. C2H4. Carbon has 4 electrons. 6, 2, 4, that is 2, 4, that is the electronic configuration. Another carbon also has the 4 electrons. This needs 4 electrons more, so 2 it will share with hydrogen, 2 it will share with hydrogen, and 2 it will share with this carbon. So carbon, and let's write the hydrogen structure. So this carbon has 1, 2, 3, 4, 5, 6, 7, 8. This. And this carbon has 1, 2, 3, 4, 5, 6, 7, 8. This. So between these 2 carbon atoms, you will not draw this, no need to draw this, just dot structure means only the dot diagrams. This is closer together, to bring it closer together. And ultimately, the structure is double bond C, C double bond, both the carbon atoms have a double bond in between them, and single bond hydrogen, hydrogen. Next is ethyne. C2H2. Carbon has 4 electrons that we will draw first. Another carbon with 4 electrons. Hydrogen. Hydrogen has 1 electron. Hydrogen has 1 electron. So let them, I'll draw the after structure, that is carbon, hydrogen, carbon, and hydrogen. Now what happens is, you draw this, we have drawn with white and yellow, and hydrogen, let us take another color because it is mismatching. So this is, so we see that 3 pairs of electrons are shared between the 2 carbon atoms. So carbon has a triple bond between the 2 carbon atoms. This carbon has how many total electrons now? 1, 2, 3, 4 of its own. This will be white in color. 4 of its own. 1, 2, 3, 4 of its own. And 1 from hydrogen, 5, 3 from carbon, 6, 7, 8. So this total is 8 electrons. And this carbon has 3 and 4 of its own, 5 from the hydrogen and 3 from carbon. So this also reaches its octet. Hydrogen, of course, has its own octet on duplet helium configuration, that is a duplet. So we write triple bond carbon and a hydrogen. This is ethyne.